Let's do flood fill. Unfortunately, I'm not going to read all of this because it's too long. You can read it yourself, but I like to think of this as just the paint bucket tool from Microsoft Paint, where you have a starting pixel or like a starting index, which is what they give you, SR and SC, and you just use the paint bucket tool on the pixel that they pass in. So any other pixel that shares the same value with the starting pixel also gets changed to the new color that's also passed in here. So you can see I apply paint bucket tool here, and all the ones get changed into twos if the ones are touching each other. Here are the companies that asked this question. So let's get into the code. So you want to solve this problem with recursion. More specifically, we can think of this as more of a DFS or depth first search type problem, where this grid is more like a graph and you're just trying to go through all the elements that are touching each other and are the same color as the starting pixel. So for example, we'll first change 1 to a 2 and then depth first in all directions, and only the top direction and the left direction in the first case is valid since they're both the original color, which is 1. These just get returned because they're 0. And then we just keep doing that for each pixel that we depth first search to. To start off, I'm going to make a global variable called original color, and I'm going to set that to image of SRSC. So now we'll get the first pixel's color that we want to match to. And this self dot makes it so that you can access this variable inside things like recursive functions, because if you don't make it a global variable, it's just going to give you an error. Now let's make our DFS function. This function will take SR and SC. And the first thing we'll do is with the base cases. First, we want to check if the index is actually in range of the grid. So this is pretty simple. It's just SR is less than 0, or SC is less than 0, or SR is greater than length of image, or SC is greater than or equals to length of image 0. So we can get the second dimension. So this whole thing is just checking if the current DFS call is inbound with SR and SC. Now we want to do some other logic with this base case. So we will add or. We need to check if the current color that we want to switch to is equal to the original color, because remember, paint bucket only works on the pixel that has the same color as the starting color. So we do image of SR SC, which is the current index, not equals to self.original color. And with this base case condition out of the way, we can just return. Now, if the SR and SC are valid, we want to change its color to the new color. So we do image SR SC equals color. And that's basically all we have to do in a single DFS call. Now, the rest of this DFS will just be calling DFS over and over for each 4 directions. So we do DFS SR plus 1 SC, DFS SR minus 1 SC, DFS SR SC plus 1, DFS SR SC minus 1. In the end, we just call DFS to SR and SC, passing in the original coordinates, and return image. And actually, we should also check in the beginning if the starting color is equal to the color that we want to change it to, because if it is, then we just don't do anything to the image. If self.original color equals color, then we just return image. If you don't have this piece of code, it'll actually still be pretty efficient, because this is just kind of an edge case where you can return immediately. But if this code wasn't here, you'd have to add an extra condition in the DFS, basically checking if the current index is equal to color, or else you'll have an infinite loop. So we need to say or image SR SC is equal to color, and then we can remove this. For complexity, this is O of n, because you're just going through all of these pixels one time. And the space complexity is also O of n, because you're making a call stack with this recursive function that's basically the same amount.